So my dear students, this unit is about file management. And in this, the first topic is about file system interface. We have file concept, a little bit about the access methods and the file protection. In file concept, we'll be learning about the file attributes, file operators, file types, file structure and internal file structure. As far as the access methods are concerned, we'll be learning about sequential access, direct access and other access methods. In the file protection, we'll be learning about different types of accesses, access control, other protection approaches, and a small example about Unix. Next is about the file system implementation. Here, we are going to learn about directory implementation, which consists of linear list and hash tables. Next is about the allocation methods. This includes contiguous allocation, linked allocation, indexed allocation, and the performance. And finally, we have NFS, that is the network file system, which will just cover the overview. So we'll be learning about the first topic in Unit 5 in this presentation. So dear students, here we are going to learn a brief overview about the file system interface. When it comes to information management, it is actually concerned with the storage and retrieval of information that is entrusted to the system. The modules of the information management are sometimes collectively called as the file system. Information management actually is one of the functions of the operating system. Earlier we would have learnt about the various functions of operating system as a resource manager. In that we would have learnt about the different resources that are managed by the operating system, which include the memory management, the processor management, device management, and the information management. So we are going to learn about the file system interface as part of the information management in the operating system. The file system is actually the most visible aspect of the operating system, which is visible to the users. Rest of the other memory management, processor management, they are not visible to the users, though they are able to work with all those aspects of the operating system. The file system, it provides the mechanism for online storage of and access to both data and programs of the operating system and all the users of the computer system. The file system actually consists of two different parts. One is a collection of files, each is storing some related data. Then next is the directory structure, which will organize and provide the information about all the files in the system. You're storing the files where you're recording your information, and the directory structure, in fact, it will help you to organize all the files where you are going to organize in which folder, which subfolder you are going to organize all this information. That is what is going to be given. Next, we are going to learn about the file system interface, and in that we'll be learning about what is the file concept. We all know that computers can store information on various types of storage media. These media can range from magnetic disks, magnetic tapes, optical disks, and nowadays we also have the pen drives and so on. The operating system actually provides a uniform logical view of the information storage so that the users find it convenient to use the computer system. When we say uniform logical view of the information system, what we actually mean is whoever creates the file and for whatever purpose it is created, all the users will find it easy to manage and manipulate those files for whatever purpose it has been created. We can say that the operating system abstracts from the physical properties of its storage devices to define a logical storage unit, the file. Now, what does it mean? On the storage media, the file will be stored in some format, and this format is hidden from the user. Suppose, for example, you have a text file in which you are storing the name, the roll numbers, and the average of all the students in a class, just for example. Then These details will be stored in terms of zeros and ones or in whatever format it is stored on the operating system. But whereas to the user, it is just visible as the set of alphanumeric characters. So that is what we mean by saying the operating system abstracts from the physical properties of its storage devices to define a logical storage unit, the file. The files are mapped by the operating system onto the physical devices. These storage devices are usually non-volatile, so the contents are persistent through power failures and system reboots. So what does it mean by saying non-volatile? You all know that the storage will retain the details of the files even when there is a power failure or even when somebody reboots the system. Next, we are going to learn about what is meant by a file formally. So here a file is defined as a named collection of related information that is recorded on the secondary storage. Related information means in one file you will be storing the details about the students. In another file you will be storing the details about the items. Yet in another file you will be storing about some EB information and so on. From the user's point of view, a file is defined as the smallest allotment of logical secondary storage. That is, data cannot be returned to secondary storage unless they are within a file. So whatever information you want to store, you have to put it in a file and then store it on a secondary storage. In general, a file is a sequence of bits, bytes, lines, or records, the meaning of which is defined by the file's creator and user, both. So, depending upon what is the user's requirement, the file creator will create the files accordingly. The concept of file is thus extremely general. There are many different types of information that may be stored in a file: source programs, object programs, executable programs, numeric data, text, payroll records, graphic images, sound recordings, and so on. So we can say that a file has a certain defined structure which depends upon its type. So whatever the type of the file, it will have a internal structure accordingly. We can say that a text file is a sequence of characters organized into lines and possibly pages, depending upon the size. A source file is a sequence of subroutines and functions, each of which is further organized as declarations followed by executable statements. This is true with almost all the language programs that you have written so far, be it C program or C++ program or Java program or any other program in any programming language. Next, we come to the object file. It is actually a sequence of bytes organized into blocks understandable by the system's linker. The linker is the module which will link the different libraries to the file. An executable file is a series of code sections that the loader can bring into memory and execute. We're going to learn about the attributes, the file attributes. A file is named for the convenience of its human users, like you and me, and it is referred to by that name. A name is usually a string of characters. For example, we can name a file as example.c. Some systems differentiate between upper and lowercase characters in the names of the files, whereas other systems consider both these cases, both the uppercase and the lowercase, to be equivalent. So when a file is named, it becomes independent of the process, the user, and the system that created it. A file has certain other attributes which vary from one operating system to another, but typically consists of the following. First and foremost, we have the name. The symbolic file name is the only information that is kept in the human readable form. Like for example, the example.c. Next is the identifier. This unique tag usually is a number. It identifies the file within the system, inside the system. It is the non-human readable name for the file. Next is the type. This information is needed for those systems that support different types of files, like the text files, binary files, audio files, video files, and so on and so forth. Next is the location. This information is a pointer to a device and to the location of the file on that device. Like, where is the example.c stored on any device, secondary storage device. Next is size. The current size of the file in bytes, words, or blocks, and possibly the maximum allowed size are included in this attribute. What is the size of the file? Next is the protection. It includes the access control information and it determines who can do the reading, writing, executing, and so on. Finally, we have time, date, and user identification. This information can be kept for creation, last modification, and last use. These data can be useful for protection, security, and usage monitoring. Next, we are going to learn about the file operations. We have already learned that a file is an abstract data type. To define a file properly, we need to consider the operations that can be performed on files. The operating system will perform the following basic file operations. So when you take any operating systems, all these different operations can be performed easily. First is creating a file. To create a file, two steps are necessary. The first step is space in the file system must be found for the file. You have to decide whether there is enough space to create that file. Second, an entry for the new file must be made in the directory. The directory entry records the name of the file and the location in the file system, and possibly some other information. Writing a file is the next operation. To write a file, we make a system call by specifying both the name of the file and the information to be returned to the file. Given the name of the file, the system it searches the directory to find the name of the location of the file, whether that file is already existing or not. The system must keep a write pointer to the location in the file where the next write is to take place. The write pointer must be updated whenever a write occurs. Reading a file. To read file, we use a system call that specifies the name of the file and where in memory the next block of the file should be put. That is, you have to take the contents from the secondary storage and shift them to the primary memory for whatever processing that is required. Again, the directory is searched for the associated directory entry and the system needs to keep a read pointer to the location in the file where the next read is to take place. Once the read has taken place, the read pointer is updated. That is to the next location from where the next read is to take place. A given process is usually only reading or writing at any given point of time in a file. And the current operation location is kept as per process current file position pointer. For every process, what is the current file position pointer? Both the read and write operations use the same pointer, saving space and reducing the system complexity. Positioning within a file. The directory is searched for the appropriate entry and the current file position is set to a given value. This operation is also known as a file seek when you are trying to search for some information. Deleting a file. To delete a file, we search the directory for the named file, that is a file that is already existing. Having found the associated directory entry, we release all file space so that this space can be reused by other files and erase the directory entry. Next is truncating a file. This is different from deleting a file. Let's see how. The user may want to erase the contents of a file but keep its attributes like the name and other things. Rather than forcing the user to delete the file and then recreate it, this function allows all the attributes to remain unchanged except for the file length, but allows the file to be reset to length 0 and release its file space. Next, we'll be learning about some information which is associated with an open file. First one is the file pointer. Many systems do not include a file offset. In such systems, as part of the read and write system calls, the system must track the last read-write location as a current file position pointer. This pointer is unique to each process which performs operations on the file and therefore must be kept separate from the on-disk file attributes. Whatever attributes that are associated with the file on the storage media. Next is file open count. As files are closed, the operating system must reuse its open file table entries. That is a table that contains the details of the files that are open. Or it could run out of space in the table. Because multiple processes may have opened a file. The system must wait for the last file to close before removing the open file table entry. So the file open counter tracks the number of opens and closes and reaches 0 on the last close. The system can then remove the entry. Next is the disk location of the file. Most file operations, they require the system to modify data within the file. The information needed to locate the file on disk is kept in memory so that the system does not have to read it from disk for each operation. When we say memory, here we mean the primary memory. Finally, we have the access rights. Each process opens a file in an access mode. This information is stored on the per process table so the operating system can allow or deny subsequent input-output requests. Like some of the access rights are read only, write only, execute only, or read and write but no execute, and so on. About some of the file types. First, we have an executable file. It may have an extension as .exe, .com, .bin, or anything, or maybe no extension at all. The main function of an executable file is it is ready to run machine language program. Next is the object file type. It may have the extension as .obj or simply .o. It is actually a compiled machine language, but it is not linked to any of the routines. Then we have source code. It may have the extension as .c, .cc, .java, .cpp, .py, and so on. So it represents the source code in various languages. Next is batch files. The usual extension are .bat and .sh. .bat if you are working on DOS and .sh if you are working on Unix or Linux or any other Unix-like operating system. These will contain commands to the command interpreter. What are the different commands that should be executed in a particular order? Next is the text files. They can have the extension as .txt, .doc and so on. It contains textual data and documents. Then we have the word processor files that usually has the extension as .wp, .tex, .rtf, .doc and so on. These are the various word processing formats that we have. Then the library files .lib, .a, .so, .dll. These are libraries of routines for programmers. Then we have the print or view file type. The extensions usually are .ps, .pdf, .jpg. They contain the ASCII or binary file in a format for printing or viewing. Next is the archive type of files, which contain the extension as .arc, .zip, .tar. These are the related files grouped into one file, sometimes compressed for archiving or storage. Next is the multimedia files, which has the extension as .mpeg, .mov, .rm, .mp3, .avi. They are the binary files containing audio or audio-video information. The next topic is file structure. The file types also can be used to indicate the internal structure of the file, how the information is organized within the file. Source and object files have structures that match the expectations of the programs that read them. Then next we have certain files that must conform, that must follow a required structure that is understood by the operating system. For example, the operating system requires that an executable file have a specific structure so that it can determine where in the memory it has to be loaded and what is the location of the first instruction in that file which has to be executed. This point brings us to one of the disadvantages of having the operating system support multiple file structures. That is, the resulting size of the operating system is cumbersome. It is huge because it has to have the information about all the different file structures. If the operating system defines 5 different file structures, it needs to contain the code to support these different file structures. In addition, it may be necessary to define every file as one of the file types supported by the operating system. Some operating systems impose and support a minimal number of file structure. This approach has been adopted in Unix, MS-DOS and others. Last topic in file concept is the internal file structure. Internally, locating an offset within a file can be complicated for the operating system. That is, where is that particular offset? Disk systems typically have a well-defined block size determined by the size of a sector. We all have studied that the disks are divided into number of sectors, a number of tracks, and then the cylinders. So in disk systems, everything is well defined. All the disk input output is performed in units of one block, that is one physical record, and all the blocks are of the same size. It is unlikely that the physical record size will exactly match the length of the desired logical record. Most of the times it doesn't happen so. The size of the physical record will be different from the size of the logical record. Logical records may even vary in length. Packing a number of logical records into physical blocks is a common solution to this problem. So you are going to combine number of logical records into one entity, and this we are going to call as the physical block, and this process is called as packing. The logical record size, the physical block size, and packing techniques, they determine how many logical records are there in each physical block. The packing can be done either by the user's application program or the operating system.